All right, let's get ourselves set up here. All right, we are on our way. Another day, another week, another worry. So in Chapter 8, we're going to be doing logical functions and selection structures. And this is where we are able to start doing things like making a program that can make pretty good decisions now based on input and based on the program that we write. You could say that this is the beginning of computer intelligence. So far, mostly we've just kind of input things and the computer spit back things, and that's about it. Maybe done some very simple calculations or something, but this time we're going to allow it, we're going to be able to write programs that can make choices. So the way that we do that is we use what's called excuse me, Boolean logic and Boolean selection. What Boolean means is essentially you give the computer a choice between yes, no, right, wrong, true, false, 1, 0, black, white. You know, a Boolean means that there are two choices to choose from, and the computer chooses one of those choices. And computers are very well suited to that because computers are digital machines, which means they already have things that are on, off, 1, 0, yes, no, already built into them. In other words, they're transistors. So this is something that computers can do very quickly and very well and very efficiently because of their internal structure. So we're going to start off with some mathematical ideas like this. So let's go ahead and define some variables here. We'll define x to be equal 5. We'll go ahead and suppress that. And we'll let y equal 1. Find that there. Whoops. Apparently I did that. Goofy. Y equals 1. Now we're going to use one of the Boolean operators in MATLAB that's built into MATLAB, which you're probably familiar with, the less than sign. So x less than y. So what this does is it asks the computer a question. The question is very simple: is x less than y? And then we hit return and it gives an answer 0. So MATLAB knows how to answer questions yes or no, true or false, but it uses 1, 0 for true and false. 1 is a true, 0 is a false. And since x is not less than y, it returns 0, which is false, of course. And then if we did the exact opposite, instead of x less than y, y less than x, then the answer, of course, would be true. And MATLAB can do this as well for arrays. Since MATLAB is designed to work with arrays and matrices, it can do it with arrays and matrices. So we can define x to be equal to 1 through 5, the array 1, 2, 3, 4, 5. And we can define y, well, let's just leave y as it is. Y right now is equal to 1, right? Let's just do that. And let's see if x is less than y. And what it does is it can return an array of answers now. And this array of answers has 0, 0, 0, 0, 0, right? So it answers 0 because x is not less than y when y is equal to 1 and x is equal to 1, because they're both equal to 1 and neither of those is less than the other. They're equal to each other, so it answers false. That's something to remember about the less than or the greater than feature. If you are equal to that number, it will return false. It won't return one or the other. It will never return true. If you use less than or equal to, which we can do, So if you do a less than equal to, like this, that is another function that MATLAB recognizes, and it will return now a true for the first one in x, where x is equal to y, because it is less than or equal to y, and then all the rest of them are false. Right? You can also do this for, we could define y to equal x minus 4, so that y is always less than x, and then ask if x is less than y, right? It's always false. Or we can ask if y is less than x, and it will always be true. Or we could ask if y is less than or equal to x, and then it's always true also. Right? So these are some of the Boolean operators. They are not the only ones, and they're called relational operators in this book. But that's fine. So you have less than, greater than, less than or equal to, greater than or equal to. And then we also have an equal to, so we can use that one. You use a double equal sign to ask if something is equal to something else. It'll return your Boolean answers there, your falses across the board. And then you can also ask if it's not equal to something. You put a little, this is called a sigilia, or whatever it's called. It's shift and the accent mark, which is to the left of your 1 number on your number board there. And that asks if y is not equal to x. Now, why would this be useful? Well, this would be useful in asking a question. You can ask MATLAB a question, well, in not asking a question, but it would be useful in using the answer to one of these questions to determine the next action in your program. So you could use this to ask MATLAB if y is less than or equal to x, and then if it is, you could tell MATLAB to do something if it is less than or equal to x. And if it's not less than or equal to x, you could tell it to do something else. And that's where we're getting at. That's where what we're shooting for. There are also logical operators, which are at the bottom of page 278, which allow you to combine different Boolean operators or relational operators. So you can do, for example, let's go ahead and do their example. Their example's a lot of typing, but that's okay. We have x equals this thing 1, 2, 3, 4, 5, and then they have y equals -2, 0, 2, 4, 6, and then they have z is equal to 8, 8, 8, 8, 8. Okay. Good enough? So we've got these things, and we want to know now, let's say, where is z greater than, x, and, so we put in this ampersand, z greater than y. So we're asking two questions at once, and when you ask it with this and in there, that means that it will return a true for every situation where both of these things are true. It will return a false where both of them are false, but it will also return a false if one of them is true and one of them is false. Both of them have to be true for this particular relational statement to be considered true. So when we hit enter, whoops, matrix dimensions, apparently one of my matrices is bigger than the other one. Oh, this one, y, is not correct, so let's fix y. Y is -2. There we go. Now we'll do this again. So we were asking when is z greater than x and z greater than y. It turns out that z is greater than x and y in every case, in every single index of these arrays. So it's always true. 1, 1, 1, 1, 1, 1. Now if I ask the same question when is z greater than x and z is less than y, it turns out that is never true always. Never is z greater than x and less than y. So you've got zeros across the board there. But you could ask, when is z greater than x or? So the or operator is the straight up and down bar, which is right above your return key. Should be right above your return key with a shift. That's your or operator in MATLAB. So if we hit that, z is always greater than x. It's never less than y, but it's always greater than x. So one or the other of these will make this true. And so it turns out that the first one always makes it true. But you can also use the not symbol. Let's see. They do an example with these. Let's do the other example they do. They do an example where when is x greater than y? Is x ever greater than y and is, or x greater than z? So we're going to do an x greater than y or x greater than z. And it turns out that that is true in 3 of these instances, where x is greater than y or x is greater than z for the first 3 for the first 3 indices or first 3 elements of each of these arrays. But for the last 2, it's not true for either of them. So it's completely false. And then, let's see, they don't use an or here, but you can't, I mean a not. So if you use a not, then it essentially changes the and to what we call a NAND, which is a not and, so it needs to be this thing and not this other thing. So if we go back to our and statement right here, z is greater than x and not greater than y, or not less than y rather, would look like this, shift not and z greater than y. I believe that's how it goes. Nope, not the way it goes. It might go after, or it might be a completely different, yeah, there we go. And it's not greater than z, or not less than y. So whereas the cases where z is greater than x and it's not less than y, it's only these 3 here, right? And this starts to get a little bit complicated as you start to think about the different ways you could put these together. You can string out a whole bunch of these different things, putting the relational operators together with the logical operators, and make a really strange logical path. But this is what we call logic algorithms. These are kind of like logical programming to sift out the exact answer that you want. And it's a very important part of programming, this idea of logic. It's used in just about every kind of programming you can imagine. Let's see. Oh, the other ones are the exclusive OR. Excuse me. So the exclusive OR. Let's see, what's the best way to explain the exclusive OR? I'm looking for an example that they use, but I don't see one that they use. They don't use one. Because I can't remember the exact definition of the exclusive OR. Does anybody remember that? Anybody take a logic class? Okay, let's look it up. So the exclusive OR, this is done. They use this in many different types of things, not just programming. But the exclusive OR there you go. It gives a true when the number of true inputs is odd. let's do this right here. Or, but with the single chance that if both parameters to the operation are true, the answer is false. Okay, so this one, and I was wondering if that was the case, but that's simpler than I thought. I thought it was going to be more complicated than that. So essentially the exclusive OR says that only one of the two operations can be, or one of the two things can be true. If both of them are true, then it's false, if that makes any sense to you. But let's go back to this and look at an example of it in MATLAB. So the exclusive OR, which is shown as the XOR, just spelled out. So you might have this X greater than Z exclusive OR XOR Z less than Y. That exclusive OR says that either this one is true, it wants either this one to be true or this one to be true, but only one of them. Like before when we used the OR, if this one was true or this one was true and they both were true, that was fine, it came out true. But now it only wants one of them to be true, this one or this one, not both, and then it will return whatever it returns. Now we have to figure out how to use that.
Unexpected because the X.
Hold on a second. So the logical difference elements S and T, the result is logical, one true, S, same dimensions, or one can be a scalar. I don't think it wants us to use, let's see. So it's the logical symmetric difference of elements S and T. So this one actually is used as a function rather than as a operator. And that's kind of strange. So in this case it wants us to do XOR like this. So X0 XOR and then put our values into it like a function. Right, like here, right? I wonder if it'll allow me to put in logical Boolean operators in there. Let's just put X comma Y in there and see what happens. So in this case, what it's doing is it's looking at the differential. So it's looking at if they're different, I think. So X and Y were what? What's X? What's Y? So X and Y. False, so it said second one was true. Why would that one be true? I don't know why. And the other ones are false. So it's the logical symmetric difference of elements S and T. Whether S or T, but both is non-zero. Okay, so if S and T are both 0, then it's true. No, it's false. If they're both non-zero, then it's false. Okay, so it's only going to answer, it only answers true.
If one's 0 and the other one's
if one's 0 and one's non-zero, that's right. So it's looking at a difference in number or 0, essentially, here. I don't know why they put it in with their logical operators, because it can't be used as a logical operator. But there should be a version of the exclusive. We can use the exclusive with the OR like this. So if we do this, for example, and we do the OR normally like this, and then we put the not, that should be an exclusive OR as well, I think. And it looks like it is. So that would be the exclusive OR, I believe, if you're using it as a Boolean or as using it as a logical operator. But if you want to use it as a logical function to determine whether something is 0 or non-zero, then you use it as a function. So
shouldn't they be equal to them or not?
I'm sorry?
Shouldn't they be equal to them? I mean, you got all ones across when you did the with the line and the tilde on it, but
No,
when
no.
you hit it up above,
No, they wouldn't be equal, and that's what I was trying to show. I was trying to show you that this is not what they say it is.
Okay.
This is not the exclusive OR that they say it is. This is the exclusive OR, I think, that we want to be using. So it's the OR with the not after it. So it's this one or this one, but not both. I think that's true. Let's see. Let's do it with X and Y since we have X and Y right here. Let's do Y, X. That's the same thing. So we'll do it this way. Right? Okay, so this is if Y is greater than X or if X is greater than Y. And it's an exclusive, and these can never be exclusively true. So let's do this. Oops, let's do the same thing again, except let's do an absolute equals here. Okay, so what is X and what is Y? X is this. The numbers do come together right here. So this is where it should be true still, but it's not. So that's not what I was thinking it is. So I'm not sure if they actually have an exclusive OR. That actually is going to help us here. Not working for me. Okay. Well, that's okay, I suppose. Logical, no, true. So I guess the way to do this, I guess the way to use this exclusive OR is to do your logic first. So we do this, for example, we do this first, for example. Oops, not that one. We do this one first, and we get an answer like this, and then we can use no, that's not going to work either, because we need two things. I don't know. Let's just keep going and see if they use it somewhere, and maybe that will help us to understand it. To tell you the truth, I've never actually used the exclusive OR in a program, so I have no experience with it other than just looking at it just now for the first time. Like the only thing I can think where it would be useful in a logic argument is if you do two logical expressions like this, and then you get two of these arrays that have ones and zeros in it, and then you want to differentiate when you have zeros together and ones together in the same spots in the arrays, in the two arrays, and then you would use that XOR with those two arrays. And then put those two arrays in here, and that could be useful. I could see it where you're trying to find out where they match up and where they don't match up, where you have two zeros and where you have two ones and where you have one of each, because then the XOR will tell you that. It'll tell you where one of your logic functions gave you the same answer both times, where it gave you a different answer each time, and that I think would be useful. I can't really see where you would use that at this level of programming, which is maybe why they haven't given an example of it here. But I could see it being useful in a higher level of programming. There's all kinds of things that I could think of for that actually, but I think we'll just step forward for now. But the whole idea at this point is to use the relational operators on page 277 together with your logical operators on page 278 to start creating some kind of a decision process where you're looking at something is maybe greater than something else, something is maybe equal or not equal to something else. These numbers, of course, are going to be inputs, or they're going to be calculations, or they're going to be something else that is in your program that will be used then to make some kind of a decision and move on from there. So the next thing that we have to learn then is we have to learn how we're going to map out this decision-making process. And this takes us to our homework. So your homework for this week starts off with a Word document. Let's go to the homework really quick. Can't remember if I have to put my whole email here or not. I think I do. All right, so weekly assignments. This should be like week 7 or something like that.
8.
Week 8.
Week 8, yeah. It's called flow charting document.
Exactly. So if you open up this flow charting document in here, they give you a, where did it go? Oh, here it is. Flow charting document should open up in Microsoft Word. And it's going to give you a tutorial on how to flow chart. So flow charting has kind of this accepted methodology that you use with different shapes meaning different things and different lines and all kinds of things. It's essentially a way to diagram out a decision process and a flow of information, flow of data, a flow of logic, however you want to think about it. So you're going to read through this. There are plenty of videos online if you want to know more about flow charting or want something cleared up. There's lots of help with that online, or you can email me and I can help you as well. Excuse me. But you have all these different shapes. You have a shape to start or end the program. You have a shape for computational things, input and output, and so on and so forth. They even have shapes that are really outdated, like a magnetic tape one or a magnetic disc one. I love those. Those are great. Usually this one here, the magnetic disc one, is used just for general storage to the computer. You know, you're writing that out to the computer. I don't think the magnetic tape one is used anymore at all, so I wouldn't worry about that one. Annotations are kind of like your comment lines, right? And then display is stuff that's printed out to the user on the screen or on paper or whatever else. Then you have, of course, decision making and branching. That's where this right here, this diamond shape, is where your Boolean logic stuff is going to happen. This is where you're going to make decisions. Is it greater than or less than? If it's greater than, it goes one way, less than, it goes another way, or maybe equal to, it goes another way. You can have different choices, and your information or your data or whatever can flow one way or another depending on whatever decision you've made at that particular point. You want to not put too many decisions into one of these things. Usually in a program, you'll have 1 or 2 decisions in one of these little nodes. Each one of these things is called a node, I think. I think that's what they call them. You don't want to put any more than one or two of those into those things. Usually it's just one, just to not to complicate things too much. And then they have some examples down here. So for example, we have a Boolean decision right here, yes or no, 1 or 0, on or off, whatever. Here we have a three-way decision where you can be less than, greater than, or equal to 0. So this one is essentially a 2-decision process. This is a 1-decision process. 2 decisions will generally have 3 ways to go. 1 decision will have 2 ways to go. And then the flow lines go in between these things in the proper directions. Then they have some questions for you to answer. You're supposed to fill these in and try to get the right answer from the reading. It's not that hard. You can either type them in or you can write them in and scan it to me or take a picture and upload it or whatever. And then they give you a nice little example of a very simple program, an adding program. Sum of the first 50 natural numbers, right? Notice here that they have a flow line that leaves the flow and loops back around and comes back into the flow at an earlier stage. This is what we call a loop, and this happens all the time in programming and in flowcharts. For those of you who are in my Intro to Engineering class, you probably recognize this flowchart because we saw some of these flowcharts and some of the things we did last semester with engineering design process, with things like PERT diagrams. These are all based on the same kind of idea. This flow of information or flow of whatever. Excuse me. Then they have another example here of reading, writing, and printing things. Out. And then they give an example. They give one more example here, computing a factorial of a number. And then they give a blank one, where they ask you to fill in the blanks, where they want you to actually write a little program. I would not try to write this program immediately right here. I would maybe start to sketch it out, draw it out a little bit on another piece of paper, maybe write down the steps in words before you try to flowchart it. There's lots of different things that you can do to help you organize your thoughts before you put it into a flowchart. Do as many of those as you think you need to do before you try to figure out what goes in here and see if you get it right. And then they have another one here that they want you to do. And then some more questions here at the end. So make sure that you fill in both of the blank flowcharts and answer all the questions. That is part of your homework this week. And then once you're done doing that flowcharting, then you do have some actual programming questions where you use some of the things we've learned today. All right, make sure that you're getting homework in too. I'm still grading, but I try not to grade things unless I have almost everybody's homework for that particular assignment. I stopped grading at about, I can't remember what chapter it was because I had only 1 or 2 assignments completed from students for the next chapter. I want to have as many as I can get before I start grading so you can get a fair grade, so that I'm grading comparably from one to the next. So get those assignments in. I'll have a lot of time, I think, next week over spring break to get some grading done, so hopefully I'll actually get some done. Okay, so that's flowcharts. Now pseudocode. What is pseudocode? So pseudocode is kind of like flowcharting, but it's more like kind of writing out your code. And we've seen this in several of the examples. If you turn to page 284, they do a little bit of pseudocode with their flowcharting on page 285, where on the left side of in figure 8.7, they have a flowchart. On the right side, they kind of write out the things that they're doing. It's just kind of like comment lining and some basic mathematical, you just write out some math that you're going to have to do. It's like code, but not exactly like code. You might use some code in your pseudocode, but you're not necessarily getting all the syntax correct. You're not necessarily doing it exactly the best way it should be done in MATLAB. You're not necessarily defining all of your parameters or all of your variables or anything. You're just kind of mapping out what you think you're going to have to do, and just hashing things out so that you're not doing it from scratch when you actually write your code. So you've seen that in some of the examples. Pseudocode is something that a lot of programmers don't do because they find it irritating, or they just don't like working with paper and pencil. It's like they're married to their keyboard. They're permanently connected to ASDF and JKL colon or whatever. Some programmers just completely divorce themselves from paper and pencil. It's not necessarily a bad thing. Some programmers are just wired that way. They just literally think better in the computer when they're connected to their computer. But I've found that most programmers are more efficient when they write things down on paper, take a little bit of break from the screen, and kind of sketch things out on paper. It doesn't have to be an exact, perfect representation of your program, but it just helps to kind of get a different perspective, a different look at things. So pseudocode and flowcharting can help you to do that. It's also a good way to look for flaws in your programming once you write your program. Once you write your program, you can go back to your pseudocode and go back to your flowchart and say, did I do this the way I thought I was going to do it? Or did I do it some other way? Do I need to check that over? It's always a good thing to have something to check your work against. All right, so let's do some more stuff here. Excuse me. So there's a little bit of pseudocode, some comment lines on the top of page 280 where they just kind of write out the steps that they're going to use in this next little program we're going to write, where we're going to define a vector of miles per hour values, convert miles per hour to feet per second, combine miles per hour and feet per second vectors into a matrix, create a table, column headings, display the table, pretty simple stuff. You can see why a programmer would maybe not write some pseudocode for that, but that's okay. We'll go ahead and do the code and see how it turns out for us. I'm actually not sure I'm going to do this. This is not very exciting. It doesn't teach us anything new, so I'm not going to do this. I'm going to move on to something that uses our I'm going to move to page 281, section 8.3. We're going to use some of our logical functions now. So here's a new, this is actually not necessarily new. I think that we've used the find function before, but let's go ahead and do it anyway. Height. So we're going to define this height vector to equal a bunch of values. 63, 67, 65, 72, 69, and 78, and 75. So there's our height vector, and we're going to define an accept vector to equal the find function, where now we're going to tell it to find everything that's in height that is greater than 66 or equal to 66. So greater than, equal to 66, right? So maybe we're a volleyball coach and we're looking for people that are taller than 5'6". That's probably a little short for volleyball. But anyway, it's a way of finding who's, which ones are taller than, 66, greater than 66. And it gives us index numbers. Let's see, so greater than or equal to 66. We have 4, which would be 72, 5, which is 69, 6, which is 78, and 7, which is 75. So those are the index numbers from height. The 4th one, the 5th one, the 6th one, the 7th one, that are all greater than 66. They had one more, I guess. No, they had.
They have 67 and you have 37 on the second one.
Yeah, they have a 67. I have a really short person in that second spot. Two short people. Man, goodness. That's nice and short. They're like hobbits. Okay, so you can also then you can also turn around and use this this array here that we got, and you can extract the numbers, extract the actual heights by using the numbers in accept. So we're asking for just the indices 4, 5, 6, and 7, or just the values at the 4 spot, the 5 spot, and the 6 spot, and 7 spot from the height array by plugging in accept into height. And so we get 72, 69, 78, 75. So we can also define something as decline, very similar to what we defined as accept. And we can find everybody who is less than 66, right? And we're not going to allow anybody who's 2 feet 11 inches to play volleyball with us. No hobbits to play volleyball. That's just discrimination there. Okay. Of course, down below at the bottom of page 281, they actually use the display function to print out a sentence that says the following candidates meet the height requirement, and then you fprintf some candidate numbers and so on and so forth. So you can do that. That's something that you learned to do in the last chapter. Certainly not beyond our capabilities. You could also do something like they do on page 284, where they're searching for patient numbers at station numbers with temperatures above a certain temperature. I guess they're not actually doing that. What are they doing? Oh yeah, there. I skipped a page. So on page 283, we've got a range of temperatures, and each element corresponds to a station. So we have this array here, temp, and this excuse me, this often occurs with computer programs that are taking data. They just throw all the data in just one long row of data. So in this case, we have one at 95. I'm not going to put in the point stuff. So I've got one at 95. I've got one at 100. I've got one at 98. I've got one at 97. I've got one at 99. I've got one at 98 again. I've got one at another one at 100. I got another one at 99. One at 97. So I've got all these temperatures. So programs that take data, that are constantly logging data from some machine, like a digital thermometer of some kind, for example, will often just put the data in one after the other, after the other, after the other, for a certain number of columns or a certain number of data pieces. And that, in this case, it puts it in 1, 2, 3, 4, 5, 6, 7, 8, 9 for 9 different stations in a nursing ward or some kind of hospital ward. And so each one of these stations is represented by which column it's in here. And then maybe it would start over again at 1 and put a new one in the first and make a new row or something with 9 columns or something like that. But we have to know that that first one is at this first station and the second one is at the second station and so on and so forth. Let's see. Excuse me. Well, apparently I skipped 2 pages, not just 1 page. It's kind of funny. In my defense, my book fell in a puddle of water when they were delivering it, and my pages stick together all the time. So they actually do this on page 282 as well, where they do candidates' age and height. But you can actually, once you find things in an array, it will find them by, you can find things in different rows and different columns, and then you can arrange things by different rows and different columns. So let's go ahead and finish up this one that we're doing with the temperature, and then we'll go back and do the one with the height and the age just for practice. So the temperature one gives us this temperature array, and if we go ahead and, whoops, and I'm lying that they just put it all in a single row. They actually decide to put it in 3 separate rows, and that's fine too. So they put this in row 1, and then row 2, and then row 3. And we want this to be equal to this. Temperature equals, which means we need to have square brackets instead of parentheses. Well, I'm doing all kinds of crazy things today. So there's our temperature array. And the first thing they do is they want to find this thing here. They're going to say that element is going to be equal to find. We want to find everything in temp that is greater than 98.6, greater than your average body temperature, right? 98.6. I'm struggling to hit my equals sign apparently. There we go. So it returns 5 elements, 3, 4, 5, and 6, 4 elements. I can count too, it's amazing. And in MATLAB it counts from the top left row and column, and then across to the right. So we go 1, 2, 3, and then 4, 5, 6, or 1, 2, 3, 4, 5. This doesn't really show to it. But anyway, top row 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So 3 would be 98, 4, 5, and 6 would be 97, 99, and 98, right? Or 5 and 6. But that's not correct.
So why did they give you the ones less than 98.6 instead of the ones greater than 98?
That's a good question. I'm trying to figure that out myself. Why did it do that? Find temperature. And it didn't quite do that either, did it? Because 4, 5 is not. 2, 3.
I think it's going up and down.
It is going down the columns, which is contrary to what.
So 3 is 100, 4 is 100, 5 is 99, 6 is 99. So you have some vertical instead of horizontal. Which it shows on 283 on the bottom, has the arrow going down.
Yeah, and it says that right here at the bottom paragraph in 283 apparently. So that is actually different than other commands in MATLAB, or it's just new in MATLAB in general. I don't know, have we done this before where it counted off in a matrix? I can't remember. Let's go look back in the matrix section here. I want to make sure that this is not different from before, because it used to go across the rows, but if it does this for all matrices in MATLAB, that's fine. If it only does it when you use find, the find function, then we got to be aware of that. So back in chapter 2, I believe, let's go look. Maybe it wasn't chapter 2. Maybe it was chapter 4. So chapter 4, if we ask for...
I think the vectors, I think, are horizontal and the matrices are vertical, I think.
Yeah, I know that's, if you just have a single row vector, it always does that. But it used to do it even if you had a matrix, it used to do it that way. So I want to know if they've changed it. I can't find anything that says they've changed it, but I don't know that that's true. I'm suspecting if they changed it here, they've changed it everywhere. Let's work off the assumption that this is always going to be true in MATLAB from now on. And if we find it to be not true, remind me that it was counting down when we did a matrix and not across, so that we can make that differentiation. They do change things from time to time in MATLAB, but I would be surprised if they actually changed that. Because that just seems so fundamental. But anyway, but let's just assume that they're going to do it this way from now on. That when we're counting in a matrix, we're going to count down the columns instead of across the rows. And when we count in a row matrix, which would be like this one, in an array of just a single row and many columns, that we're just going to count straight across the row, which would be the same as counting down each column, of course, but we want to make sure that that doesn't change when we do this, when we use some other function. I don't think it will, but anyway. So it's counting down, apparently. So this is 1, 2, 3, 100, then 4, 5, 6, and then all the rest are less than 98.6. So that's good to know. And it's kind of interesting that going the other way, it counted the ones that were not. But it didn't count all of them. So. Anyway, what do they do next here? So now they're going to actually set this up now into rows and columns, which we can do. So if we define an array called row and column, if I was going to do this, I might, instead of calling it row and column, I might call it, let's see, what are they calling it on the next page? On the next page, they're calling it patient and station. So I might just call it patient and station here. Patient and station. So in other words, the row being the patient, or sorry, the row being the patient and the column being the station is going to be equal to find now, and we're going to find the same thing, temp greater than 98.6. And this time what it's going to do is instead of just counting down the columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's actually going to give you the coordinates row by column. So 1, 1 here, 1, 2, 1 here, 3, 1 here, and so on. So the first patient that has a temperature that is greater than, let's see, patient was the first one.
3.
Yeah, so 3, 1. So 3, 1 is the third row, first column, right? And then 1, 2, first row, second column, right there. And 2, 2 would be right here, 99. And then 3, 2 would be that third row, second, 99, right? Did we get them all? I think so. Okay. So the element and the patient, the patient and the station were the row and the column coordinates. There. Now, of course, the reason they call them row and column is so that it's obvious, but then now we can use them in the next thing, which is to print it off and not have to remember which one's the patient, which one's the station. And we can print it off using fprintf and print off their station number, which would be their column number or their station number here, right? And then you could also print which patient they were by using these numbers here. Apparently patient 3 is sick. Anyway, so now we actually get into using all these things. Oh, did we want to go back? I think the other example is pretty much the same, so maybe we don't go back. Actually, no, let's go back to this other one. Because it actually uses some logical operators. So let's go back. So we have, this is at the bottom of page 282. We've got some applicants. Let's go ahead and clear this stuff out. Let's see. So we're going to define applicants. And this is going to be an array of numbers. 6318. Excuse me. 6719. And 6518. 7220.
What page are you on?
280. Page 282. And we're almost there. The great thing about programming is usually when you're programming, your data is input automatically somewhere. Usually it's uploaded from somewhere or something. Usually you don't have to type it in, or you pay somebody to type it in. You pay some kind of data clerk to put all that stuff in. But there's our applicants array. We've got several rows and 2 columns of data. Obviously one of them is height, according to the chart in the book, and the other one is age in years. And then we want to sort them in some way. So we have all these applicants. Now we're going to define the applicants who qualify. We're going to pass our test. So we're going to discriminate, right? This is computer discrimination. So let's do it. So we're going to look for applicants. We want to find the applicants, and we're going to look in just a single part of the applicant's thing. We're going to look at everything in the first row. And we're going to look at, let's see, we're going to look at everything in the first column. No, what are we looking at? We want to define, we're going to look at the column 2 are also greater than or equal to 18. So we're looking at everything that's greater than 66. So everything in column 1. So we're looking at for everybody that's greater than 66. So this is all of the rows first column, right? That's what that means. I always forget how that syntax works. But this syntax, what the colon means is that everything, so if it comes in the first spot, it's everything in the rows. So it's all the rows. If it comes over here, it's all the columns. And I always forget that. So the colon means all the rows, first column. So all the rows, first column means we're looking at all the ages. So we want to look at all their ages, and we want to know when their age is greater than or equal to 66. So we're looking for older people. But we also want applicants where everything...
I think you said that wrong. I think the height is 66, isn't it? The age is the second part.
Oh, you're right. Sorry, I was looking, yeah. Everyone taller than 66, sorry. Taller than 66 inches. Good thing we're not measuring in centimeters. No, yeah, you're right. The 66 is the height, not the age. And then the age are all the is in the second column, right? So that's what we're doing here. We're looking at all the rows again, but we're only looking at the second column this time. So column 2. And we want that all to be greater than 18 or equal to. So greater than or equal to 18. Yeah, that would have been kind of short if 18 was the height. Right? But we also want them all to, so we put another and, this is another requirement, and usually people put spaces so that that and is obvious. So we also want our applicants in the first, or sorry, in the second column, their age, right? We also want this to be less than 35. So now we're really being discriminatory. That's breaking federal law right there. So if we apply this filter, and this is sometimes called a logic filter, but we're essentially applying, we're going to apply these requirements, or we're going to make these decisions and see what this returns for us, and it gives us 2, 4, and 6 as possible applicants that we're interested in. So 2, which would be this one right here, 67 and 19. 4, which would be 72 and 20, and 6, which would be 78 and 34, right? That is a tall 12-year-old. Holy crap. 6'3" at 12 years old? You gotta be kidding me. Okay, so anyway, that's using a little bit of little bit of our logic operators together with our relational operators there, like that. Then you can, of course, create another table. That's stuff from last chapter. I won't waste time doing stuff from last chapter over and over again, but you can look that up and do it if you want. And they do an example here where they actually use on page 285, 204, 285, 284, 285, and 86, where they're using a flow chart, but they don't really use any relational functions as far as I can see. No, doesn't look like it. So we won't worry about it there. So anyway, that takes us through the relational functions and logic structure. Somebody sharpening a pencil? What does that sound?
The TV's wigging out.
Yeah,
Oh.
we got the one TV's being weird.
Oh, you gotta love that. Do you guys still have some of those old TVs in your room?
No, they're all flat screens.
Oh, they're just wigging out. Somebody hit the TV screen with something. Well, that was not a TV screen. That was me blowing my nose. In case you're wondering. All right, so let's move on now to selection structures. Believe it or not, computer people get excited about this stuff. Like, it seems pretty boring, but they get excited because they think of all the things they could do with this. So this next part is even more so. This next section is going to introduce you to the first types of programming that can allow you to truly guide the computer to do something. So this is kind of the beginning of artificial intelligence. So selection structures are allow the computer to choose between different things. So now we've figured out how to sort things that are greater than, less than, equal to, whatever, not equal to. We've used logical structures to kind of make decisions on these things, to kind of guide information through a flow of information, like a flow chart kind of thing. But what if we want to now make a decision what we're going to do if one of those things is true, right? So now we've decided that our data is greater than 98.6. Now what do I do? You know, do I do something with that, or do I not do something with that, or do I, you know, set off a chain of events? Do I terminate the patient or whatever? You know, we got to make a decision at some point. And so we're going to do that now with these selection structures. And the very first one is the if statement. They call it the simple if statement because there are a few more if statements that we will add to it. So let's go ahead and clear out really quick. And we're on page 288. So let's do a very straightforward thing. If G is greater than oops. It's not going to let me do this here. Let's try this again. If G is greater than display, I think I can write this way. If not, then I'll have to write an M file. G is a small value equal to display G. Let's see what happens. Oops. So, it doesn't know what G is, but let's make a G, right? I need to enter a G actually. So I'm going to enter 67, and then I'm going to display G. I think I'm going to have to write this on M file anyway. Yeah, it's not going to run that way. There is a way to do it from the command window, but I can never remember how it's done. So let's just write a new script, and let's put this in here. All right, so let's see here. Let's run this guy. Let's call it G. G. I did not mean G. Okay. I didn't put my number up here. There we go. Now we're ready to go. Gosh, dang it. I do not mean G. With G greater than 50. It should allow this to work. Oh my goodness. Okay, let's try this again. Save. Let's try it again. Still doesn't like it. Okay. Let's try this. There we go. So if I just copy, dang it. I'm stuck in a loop. Oh, how do you end a loop? I forgot. Is it Control B? Control D? Control C? Can't remember. No way. Force, Control C. That's might be less response to. There we go. Control C. There's another thing for your tips and tricks. If you get stuck in MATLAB and you can't get out of it, Control C. Okay, so Control C got me out of that. Let's do this again. I'm going to paste my stuff in there, and I'm going to actually write end instead of emmed. There we go. It still won't let me do it. Why not? This is making me crazy. Okay, let's...
Because you put display instead of DISP on the second line. Put DISP.
Ah, thank you. I wasn't looking at my code. That's what it is. Okay, so now we got it. Now I did it again. Okay, here we go. And display. It's always good to have more people looking at your code than just yourself. Now, does that look good? It still doesn't like it. Are you kidding me?
Oh, you need to enter. Don't you have to enter a value for G?
No, it's prompting me to enter a value for G with the display code. It should, anyway. Let's see here. Okay. Well, I guess we can just choose a G before we write our code. Let's say G equals 6. Why not? Okay. That's not what I was thinking that does. What does the display thing do? I forgot. Does it actually return something? I can't remember. Or does it just display what you tell it to display? Oops. Display array of oh, so it actually doesn't. I was using the wrong one. I was thinking display did something that something else does. What's the one that, is it print or is it,
Input.
Oh, it's input. There, thank you. Good thing I can remember these things. Let's do an input one. That's the one I want to do. Okay, so if, let's start off here with, let's actually do it up here. Let's do input. Enter a number between 1 and 100. Let's put that into G. That's what we want to do. And if G is greater than 50, we'll say G is, that's what we want to do. That's what we want to do. Okay. Is it still going to give me trouble here? Oh, I remember. I did the syntax wrong. G equals. Right? Is that how it goes? Something like that. There we go.
Yeah, I got an error. Yeah.
So then you say G equals
G
the input.
equals.
Yeah, G equals input. There we go. So I enter a number between 1 and 100. I'll enter 45, and it tells me that G is equal to 45. But if I run the same thing again, and I put G is equal to 65, it actually does something different, right? It says G is a small value equal to 65. So it does something quite different. I should suppress this if I'm going to make this a real piece of code. You could also do other things in here. So you could say you could do this display. We could say G is a value greater than 50 if you want to. 50. Equal to whatever. But then there's another one that we can put in here, which is called the else if. And notice that it automatically puts it back with the if here in your formatting because it's another structure, another if structure. So I can do another one. I can say else if G is less than 50. Let's do less than 50. Say we'll display you have chosen poorly. And you could even do another else if you wanted to. Else if G is, remember that if it's equal to, you put a double equal to 50. Oops. Good night. You ran $1 million pesos. Right? So that it can do different things depending on what you enter in. And that's the whole idea behind here, is that you now have a computer that is making choices and returning things depending on what input it gets. And of course it can get more and more complicated. You can have lots of else's, lots of else ifs in your structures, and you can start to make very complex things. Although this doesn't give you many options, it does give you some. You can also have multiple selection structures up here for selecting numbers in different ways. You can select from many different things, like we did before, selecting from different arrays of numbers, selecting 2 different arrays, and all kinds of things. So you've got lots of options to start writing programs that will will accept lots of information, will make a lot of decisions, and then we'll have lots of different options for output. On page 290 and 91, they do an extension of the age. Well, I guess it's just page 291, where they do an extension of the age example. And then on example 8.2, they assign grades by percentages. So you set up a structure like this where if your grade is between 90 and 100, greater than or equal to 90 and 100, you get an A. Greater than equal to 80 and less than 90, you get a B. So hopefully you can see how that would work with else if and else if.
How does that work on figure 8.9 on page 290? If you're saying age is less than 70, well, 18 and 16 are less than 70. How does it know which one to?
So you have an else, you have an if, you have an else if, and you have an else. And each one of these things kind of does different stuff. So let's go ahead and look through that one on page 290. You start off with if your age is less than 16. So if you're less than 16, if your age is less than 16, it immediately is going to take everything that's less than 16 and put them in this box and give them one particular answer. If you're greater than 16 or equal to 16, then you'll move to the next thing. You'll only move to the next thing, though, if you are greater than or equal to 16. Does that make sense?
Okay. Yeah.
And then the next one is an else if, which does the same thing as an if, but it only does it after an if. So then it takes whatever's left and does the next thing. So if you're if you were not less than 16, but you are less than 18, so you're between 16 and 18, in other words, then it kicks you out there, and it kicks you to a new decision path. Then the next else takes you to everybody that is greater than 18 or equal to 18, but less than 70, right? And so then if you're less than 70 but greater than 18, it takes you to that next path. And then the last one, the else, just takes anything else that has not been kicked out, and it throws it into that last decision. Okay?
Roger that.
So the else and the else if have a tendency, they sort things out. And so if you get sorted one way, you don't get sorted the other way. And the else just takes everything that's left. Okay, any other questions about the if, else if, and else functions? Be aware though that these ones do very much like when you're building your own function. You need to start these and finish them. You start with an if, and you end with an end. And you can have else ifs and elses, in between, but they start with an if and they end with an end. Okay? And they may work without putting an end at the end of the function, at the end of your loop there, but you can really mess things up if you have multiples of these in there. They call these a loop. They call them a decision loop or a Boolean loop here, or a decision structure, or whatever you want to call it, selection structure. But if you don't end your structure, it still may work, but you may cause problems with structures that come after that. So it's a very good idea to always put an end after you're done. In fact, I always put an end before I'm done and then just put things in between, just so I don't forget. It's very easy to forget. Okay, now the next one, which I believe is the last one in this chapter, which is the switch case structure. And this one is quite useful. So, they have this little example at the very beginning on page 295, which I find pretty much useless. So I don't go through it. So I'm just going to skip to the first example. The best way to understand how this works is to look at an example. So let's go ahead and just jump right into it. The switch case structure, you start off with some kind of an information input, some kind of a variable definition or something. In this case, we're going to ask for some input from the user to go into this variable city. So city is going to equal the input from this question, name of city. We'll just make it short here. Name of city, right? So, and they want you to put the name of the city in single quotes because they want it to be entered in as a string. So maybe I enter in Omaha or something right here, right? Whatever I enter in. And I enter it in single quotes so that it comes out as a string, right? So I'm going to put that into my function up here.
My computer just shut off.
You running out of battery power?
No, I'm plugged in.
No. What kind of computer is it?
Hopefully I saved recently.
Yes, that would be good. If you lose your notes like that in your lab, but you saved most of them, just write me a note in your notes. Otherwise, you might have to go back and watch the video and write some notes. So anyway. I don't usually read through your notes to check them line for line that you entered everything. I just check to see that you were taking some notes during the class and that it's a reasonable amount of notes. Okay, so anyway, in this case, we're going to start off with this this input, this city, and then we're going to start with this switch, which is going to be highlighted in blue because it's the beginning of a selection structure, and we're going to do the switch city, right? So notice that I'm using the name of this variable here. So I'm switching city with something. Now I'm going to define some cases. In the case, quote, Boston. In other words, if city is Boston, if the city is Boston, then I'm going to do something. In this case, I'm going to display something. I'm going to display, there we go, display. I'm going to display clam chowder. Right? And then I have another case. Let's say my next case is Omaha. Goodness. Then I might display steak. Right? Then I might display then I might do a new case.
One. No. Okay.
What city should I choose next? San Francisco?
Two.
Francisco.
In Rice-A-Roni.
Well, that used to be the case there, but now I think in San Francisco it's nothing but like tofu hot dogs. Tofu mystery tofu. Right? Although if I go to San Francisco, I always eat what's called an It's-It ice cream bar, which is the real San Francisco treat. It's ice cream between two oatmeal cookies dipped in dark chocolate. It's awesome.
Nice.
Yeah, if you're ever in California, you got to try an It's-It. They sell them at every gas station in California and Nevada. But anyway,
My
that's your...
computer's doing updates now, so it might be a little bit.
Well, isn't that fun for you?
Yeah, it's on 30%. Yay. Thanks a lot, HP.
Don't you love when your computer just decides what you're doing is not as important as what it needs to be doing? All right, well, if your notes have saved, you know, most of those notes are saved, don't worry about it. We're almost done today. So anyway, there's my program. I'm going to go ahead and run it, save it and run it in name of city. And then I put in Omaha. I've already got city is equal to Omaha, but I'll do it again in quotes, Omaha, because I'm in the mood for a steak. And I get a steak, right? So I think that it's obvious what you can do with this. And it doesn't need to be just names. It can be numbers. It can be data. So if you have data coming in, you can choose what you're going to do with this, right? So you have a piece of, and you can do it with an array of data as well. But you can choose now, when your data comes in, you can go ahead and you can put a case. And the case can also be, can also include selection structures. It can include selection things like, you know, the case of X is greater than 4.8, and then you choose what you're going to do. You have a case for what you're going to do. And the programming under each case can be very complicated. You can do all kinds of things underneath each case. You can be calculating things. You can be graphing things. Whatever it is you need to be doing. And those are the selection structures that we teach you in MATLAB. The if-else structures and the switch case structures. Let's see if there's a good example of using the switch case that does anything different than what we've done so far, right? Not really. They do a switch case in the example 8.4 where they do a few calculations, but it's not really anything more. They do like one calculation under each case, or not even that really. But you can pretty much put any code you want into the cases. You can put any code you want to under the if-else structures, or the else-if structures, whatever you want to call them. So you've got now some more options, some more power to work with as you're building programs. You can guide the computer to do things, to do more things. Next time in chapter 9, we will do for loops and while loops, which are really powerful, which allow us to do all kinds of different things, and really take us to the end of programming in this class. Once we get through for loops and while loops, we will learn to do a couple of other things as far as using MATLAB, a couple of other things using images, matrices, but pretty much after chapter 9, we're just going to put all this stuff together that we've done and try to create bigger and bigger programs, more and more complex programs, and work you guys towards a final project that will hopefully be, a couple hundred lines of code that can do all kinds of stuff. I'd really like to do something like a video game, some kind of online gaming thing that you create your own online game using this stuff. Not terribly difficult to do, but still kind of fun. And if any of you have any ideas for a final project, make sure that you're sending me an email, because if you've seen something or you've heard of something or you just have an idea, send me and we'll see if we can make it work. But we're getting close to the end. Next week, of course, is spring break. And the week after that, I will be in McCook on Wednesday to teach this class from McCook. So what room are you guys in there?
221. We gotta look. I'm gonna look.
Okay. I might have the number here somewhere too. 229, is that what you're in?
229. 229.
Yeah, so 229, I'll be in 229 with you guys next week. So that'll be a nice little change. And I'll do all the distance learning out from there, because I'll be there for the inter-high day anyway. Even though you will have inter-high day in McCook, we will have class there in McCook at 1 o'clock, because inter-high day is over by then. And then, it's over, but it's at not 1 o'clock, noon o'clock. At noon in McCook. So we will be there at noon. And then, let's see. Yeah, we'll be doing chapter 9, and then we'll do a couple things from other chapters beyond chapter 9. But we'll be trying to just put together all we've learned to do more and more complex programming. Any questions before we break for today? We're done kind of early. All right, well, we're done then. You guys go ahead and get started on your assignments, and we'll see you next week.
Sounds good.